Hi, welcome back. And I'm sure you are just full of energy to have the next session on the real numbers, and this is on the operations on real number. In this session, what we are going to deal with is two topics we will deal with. The first one is representation of any irrational number. Irrational number on number line. And the another one is rationalizing. Rationalization of numbers, of real numbers. And real is irrationals. Normally this is for irrational numbers. So, how to deal with them? Before I will start and what the principle we have for this one. This is based on a principle. That is based on what the principle all is. The principle for this one is a algebraic formula, that is a plus b whole square. What is this one is? It is a square plus 2ab plus b square. And what is a minus b whole square? It is a square minus 2ab plus b square. Let's say I had to mark square root of a. I had to mark this on the number line. This is number line. I had to mark square root of a. This is, say I will put 0 and I have to mark somewhere where is the square root of a will lie. I had to, whatever the value of a is, it can take a value 1.4, square root of 1.4. How to find? I'm not aware about what is the square root of 1.4 is. So to know that, we have this formula. What we did? So let's say the difference of these two, a plus b whole square minus will be, if I will subtract these two, this will be cancelled and this will be cancelled. Only this will be left with positive sign. It will be 4 times of ab. But why I need? I need a. So what I did? What should I do? Let's say I do one thing. I will just divide this whole equation by 4. Let's say, first of all, I divide this by 4 to eliminate this. 4 will cancel. Now what this becomes? It becomes a plus b upon 2, and it will become a minus b by 2 whole square, and it will become ab. Now I have to eliminate b. How can I? Let's say put b is equal to 1. Put b equals to 1. What it will result in? A plus 1 by 2 whole square, a Now I have a. Or can I write it like this, square root of a whole square? This one. And what is this? Square root of a is. With this, I have square root of a can be written as, it is the square root of a plus 1 by 2 whole square minus a minus 1 by 2 whole square. So what I have? If I had to know what the value a is, if I had to find out this one, what I have to do? I have to do this thing. Square root of 14 will be 1.4 plus 1 by 2 whole square plus 1.4 minus 1 by 2 whole square under root. This is the thing I have to do. Very easy. But this is minus. So this is the thing I had to do. So let me do and tell you how this will come, how will this come, and what are the essences behind all these things. So let's see that. Operate it. I will write the formula here. Square root of x equals to square root of x plus 1. This is the thing which I'm going to do. So how to do this? So for this I have to make some arrangements. So let's say I have to draw x. So I have to use a number line, and let's say here is 0, and I have to draw root x. I have to draw root x. So what should I do? To draw root x, I will first of all, this is 0. On the left side of 0, I will mark x. I will take a distance x. Let's say this distance is x. This distance is x. I am taking this distance x. Now what I need? I need x plus 1 by 2. I need this one. Or I can normally, without any 0 also, I can mark it like this also. I can mark very easily on a number line. If I will take a number line, I will mark it here any point, and I will start from here. So what will be? I will just take a line. This point is x. So this distance is x. Okay, and let's say I mark this point as P, this point as 0, O. So I have marked OP, which is x. Now I need x plus 1. So what I did? I will add 1 to this. From here, I will add this R, which is 1. What I did? PR is equal to 1 unit. Okay, I will take this one. Now what this distance is all about? Now OR is x plus 1. I need x plus 1 half. So what I did? From here, this is x plus 1. I will take the average of this, half of this. So I will divide it by 2. So I will take the midpoint of them. Say the midpoint of them is, I will mark it. I can easily mark the midpoints. It is this one. So let's say I have whatever the value is, I can mark the midpoint. So I will mark the midpoint here. This is the midpoint, and I will take this midpoint at A. So what I have? OA is equal to AR is equal to x plus 1 by 2. Clear? It is x plus 1 by 2. So this is one thing I will have. I just divided by this one. So I have this. Now what I did? After this, what I need is, I will draw a radius, a semicircle. With the same radius, I will draw a semicircle like this. I will draw a semicircle. Now this semicircle, whatever I have drawn, this distance it will have, this distance it will have, from here the distance is also, if I will take this as B, this distance is also x plus 1 by 2 square. This distance is this one. And what this distance is? AP. What this AP is? AP is, this is x plus 1 by 2. Obviously I can write it like this, AR minus PR. And what is AR? AR is x plus 1 by 2, or PR is 1. So it will be x plus 1 minus 2 by 2, or it is x minus 1 by 2. the another term which I need. So the another term, this will be x minus 1 by 2. Okay. Moreover, since b can shift from anywhere, what I did, I just draw this line I will draw, and this line, and I will join this one. And b just shift here, I just shifted b here, this is also b, because this is a radius of this semicircle. So now what I did, this is 90 degree, this is the hypotenuse AB. Now what it becomes, AB square will be equals to AP square plus BP square. Now what is BP? Square equal to AB square minus AP square. Now what is BP? Square root of AB square minus AP square. Check. And this AB square. Now AB square, what we have, this is the same as x plus 1. So this is x plus 1 by 2 whole square, and this is x minus 1 by 2 whole square, and this under root. And according to the formula which we have here, what is this equals to? It is equals to root x. So BP is nothing, it is root x. So what we have, BP is root x. Now we know the measurement of root x. We had the measurement. What the measurement of root x is? This is root x. Now taking compass, putting the point of the compass here, I can make this radius, and if this is a number line and this is 0, I can easily mark here. I put 0, and then I can mark it here. Or I can take 0 as here. I can take 0 as here, and with this I will draw like this. What I did, I will draw like this. This is the another semicircle I will draw, and this semicircle here, this is the point which is resulting root x. This distance is root x, total distance. I will rub this, and this distance is root x on the number line. So this is how I can draw any number on the number line, any irrational number I can draw on the number line with the ease. I'm sure it is clear to you, and obviously it is looking some complicated maybe, but let me make you understand with a numerical example. Let me take a numerical example. Okay, because my aim is not just to give you the session, my aim is just to put you the why it is happening like this. So why this is happening, we have explained it. Let's say we have to mark square root of 1.4. Okay, so how to mark it? So here under root x, so what we have, x is equal to 1.4. So first of all, on the number line, this take point A here, I will mark 1.4 on the number line. This is B I will take, and from B I will mark again, I will mark a P which is 1 units. So AP is now equals to 1.4 plus 1 equals to 2.8. So this is AP. From here to here, this is AP, this is this one, and I will take the midpoint of this. By taking a midpoint is again perpendicular bisector I can draw like this, perpendicular bisector. From putting point here, I can draw these two arcs. From here I can draw these two arcs, and if I will join these two arcs like this, so what will happen, they will meet at a point. Let's say this point is the midpoint of them, and since this point is midpoint, I will mark it as R, or any number I can take. And with that, I had drawn a semicircle. A semicircle is drawn here, and this, I know this point, this is what is this? Is 1.4 minus 1 by 2, it is 0.4 by 2, it is 0.2. So it is 0.2. This line, if I will draw a perpendicular here, this is making 90 degree here, and I will join this, I will put it as PQ. So in this triangle, this is radius, same as this one, this is equals to 1.4. okay, this is equals to 1.4 and this is 0.2, and when we have this one 2.8 is here, so half of 2.8 is 1. Okay, sorry, this is 2.4, it is 1.2, 2.4 and 1.4 minus 1, this is 0.2 and it is 1.2. okay, so this is 1.2, and with this is, we can directly put it 1.2, okay, whole square minus 0.2 whole square under root, and it is equals to 1.2 plus root plus, or I can directly make it like this, 1.44 plus 1.44 square, and then I will subtract, and what it becomes, under root 1.4. So directly it is 1.4. I will take this as 1.4 and just mark a circle here like this, and this point where it comes, this point represents 1.4 under root on the number line. Clear? So this is how we can represent any real number on the number line. After this, I have promised you with the another part of this one. The another part of this one is rationalization. Now, what is rationalization is? Rationalization is a process. It's a process. It is a process of rationalizing okay, or I can say not rationalizing, I will get it is a process of making irrational numbers to rational. Okay, and the term by which it is multiplied or used is known as rationalizing factor. Rationalizing factor. Okay, so this is what is rationalizing factor and what is rationalization is, and what the process this all involves. For example, root 3 is an irrational number. I know this is an irrational number. So if root 3 is a rational number, by what I can multiply this so that it becomes irrational. So root 3 can be multiplied by another root 3 and it will result into root 3 into root 3, and it will result into root 9 and it will result into 3, which is a rational number. So for this number, root 3 is a rationalizing factor. This is a rationalizing factor because it is helping him to become a rational, and moreover this total process is known as rationalization. So this is what we are going to study, how to make a irrational number irrational and the process. Okay, so this is rationalization. So let's say come up with some examples. And the question will come in this form. What is rationalizing factor of square root of 8 below? So this is a question. How to do this question? Easy one, but normally what a student do mistake is, what they are doing mistake is, the mistake they do is, they take as the number is, let's say n is a number and the number is root 8. What normally they do is, they multiply this by the multiply by root 8. So what we get? N becomes root 8 into root 8. It becomes root 8 times of 8 and it becomes 8. This is a rationalized. It has been rationalized, but is it perfect? No, it is not perfect. Why it is not perfect? Because the rationalizing factor should be in a simplest form. It should be in the simplest form and smallest of all. Say, it is like this. If you need 100 rupees and you can do whatever you want in only 100 rupees, but you can also spend 1000 rupees for that also. But is it necessary to spend 1000 on that? No. The same is here. When it can be done with the smallest term also, why we are doing it for higher term? So this is what we have to know. Let's see how it can be. It is like this. N is this. So n can be also written. Just try to make it in the simplest form. What is? It is 2 into 2 into 2. It becomes 2 times of 2. Now, this is a rational. It is a rational. So this is only the part which is irrational. And I have to make this rational. My motto is to make this irrational to be a rational. So how will I do? Only very simple. Multiply by root 2. So n becomes 2 root 2 times of root 2. It becomes 2 into 2 into 2. It becomes 2 root 4. 4. So how easily I have done my work. My work is very easy. What I did is I multiplied this by square root of 2. So this root 2 is rationalizing factor of root 8. Minimum thing we need. We need minimum thing. Why we take the greatest one? Okay. Next. Now how to rationalize fractions. Fractions, or we can say denominators. Normally what we do is we rationalize the denominators. Okay, so how to rationalize that? Let's say I have an example. Let's say we have 3 over root 7. So what we do is we had to rationalize the denominator. We have to find out. Now we can do it like this: 3 over root 7 into root 7 into root 7. We just rationalize the denominator. In rationalization of the fractions, we normally rationalize denominators. You can also have as rationalize denominators. How? It will be 3 root 7 upon 7. This has been rationalized, and this is actually the the form in which normally we have the answers. This is the form. Denominator should be in a rational form. Numerator, whatever it is, no issue, but we had to have this one as in a rational form. Clear? Let's say they have more examples. We have 1 upon 2 minus root 3. Another example with us. So what we will do? We know wicket is we know that. I can say it, we know that. Even then you can also wicket. We know that. We know that a minus b into a plus b equals to a square minus b square. And if it is in this form and it is in this form, what it becomes? It becomes a square root of, and it becomes a minus b. See how simple this is. These two numbers are irrational, these two are irrationals. When these two irrational numbers are multiplied by them, they become rational. A is rational, b is rational. So this is how, what are we doing is, we are multiplying them by their conjugates. The conjugate of, see, this is with this formula, we normally know conjugate of a minus b equals to a plus b, and a plus b is a minus b. So this is the way in which we normally do conjugates of a minus b and a plus b. So here what we'll do is, we just multiply both with the conjugate of that. 2 minus root 2, root 3, conjugate is 2 plus root 3, and it here is 2 plus root 3. And what we did, 2 plus root 3 over, it is 2 square minus root 3 whole square. It is upon 4 minus 3, it is 2 plus root 3 over 1, and it is 2 plus root 3. Very easy. So this is how they have been rationalized. Clear? Last question of this one, I just give you an example. A question I will give you, and we will try to solve that question also. Find value of one plus So this value we have to find out of this one. Now again, this seems to be very difficult for a student who doesn't know rationalization. For him, what will happen is, he just start taking the LCM of all these, and which is a tedious job, and even then I can't do it. I can't take the LCM of all of them. It is not my work. So being a human being, I have to apply my mind. I'm not like okay. So what mind I have to apply here is, let me rationalize them. Let me check it whether, because we have root 2 here, we have root 3 here, root 3 here. That means the last term is the last term of the previous is the first term of the next one. So we try to rationalize them. Let's say I will rationalize them, and the rationalization becomes like this. It becomes, I will rationalize it and multiply it by, let's say, root 2 minus 1, or I will say 1 minus root 2. I will take. I will rationalize this. Root 2 minus root 3. And so on I will do till root 8 minus root 9 upon root 8 plus root 9. Root 8 minus root 9. What I have is, I have 1 minus root 2 over 1 minus 2. 1 minus 1 square, and I will have root 2 minus root 3 over 2 minus 3. I will have root 3 minus root 4 upon 3 minus 4, and so on. I will have root 8 minus root 9 upon 8 minus 9. I will have 1 minus root 2 minus upon minus 1 plus root 2 minus root 3 upon minus 1 plus root 3 minus root 4 upon minus 1 plus root 4 minus root 5 upon minus 1, so on up to root 8 minus root 9 upon minus 1. Just divide them by minus 1. It is root 2 minus 1 plus root 3 minus root 2 plus root 4 minus root 3 plus root 5 minus root 4 plus root 6 minus root 5 plus root 7 minus root 6 plus root 8 minus root 7, and lastly we have root 9 minus root 8. You check it. This root 2 will be cancelled by this. This 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 by this, and this by this. What we have been left is minus 1 plus root 9, which is minus 1 plus 2 or plus 3, and it becomes 3 minus 1 equals to 2. So the answer of whatever we have here, the answer is 2. So this is application and magic of rationalization, how easily we can solve this any type of question which has been based on this. This is a question which have been in exams. We have this type of question in NTSC type examination, which are the part of which is organized by NCRT, and I will prepare you for that in class 10th. In class 10th we have that examination for you, so we will go for that. So this is all for this session, and let's say enjoy it. Have a nice time. Bye. Thank you.